What is going on, guys? Welcome back. In this video today we're going to learn how to customize the process of training a neural network in Keras by using callbacks. We're going to learn what callbacks are, we're going to take a look at a couple of very useful callbacks, and we're going to learn how to create our own custom callbacks. So let us get right into it. Alright, so callbacks are classes or objects in Keras that allow us to customize behavior in the training process or to add behavior to the training process when training a neural network. For example, you might want to have a custom logger, you might want to save the models in a certain intervals that you're training, you might want to stop if no progress is being made, you might want to change the learning rate while the model is training, so in different epochs you want to have different learning rates and so on. All these things can be customized using callbacks, and this is what we're going to learn about in this video today. Now, first of all, you need to open up a command line and install TensorFlow if you don't have it on your system yet. So just pip or pip3 install TensorFlow, and once this is done, you can start with the imports. So as I said, what I want to do in this video is I want to show you a couple of callbacks that are already defined in Keras, in the Keras API, so you can go also to the documentation and take a look at them. I'm not going to cover all of them, but a couple of them, and then I'm going to show you how you can also implement your own custom callback for whatever you want to do. So we're going to start here by creating a simple neural network that classifies handwritten digits. So we're going to use the MNIST dataset, and we're going to train a neural network on this dataset. So nothing special, we've done it a couple of times on this channel already, but I want to then show you how we can customize the behavior of the training process by adding a couple of callbacks. So we're going to say from tensorflow.keras.models, we're going to import a sequential model from TensorFlow Keras layers. We're going to import a flatten layer, a dense layer, and a dropout layer from tensorflow.keras.optimizers. We want to import an atom optimizer. Now, first of all, also from TensorFlow Keras datasets, we want to import the MNIST dataset. And then, of course, we also want to import the callbacks. Now, I'm going to start with just one callback, or actually I'm going to do the import when we use the callback. But the basic training process is now getting the data, so getting the X-train and Y-train tuple and the X-test and Y-test tuple by loading the MNIST data, so by saying MNIST load data. And then we're going to also normalize this. So we're going to say X-train and X-test is going to be equal to X-train divided by 255. This is because we have an activation from black to white, which where black is 0, white is 255. We want to have this from 0 to 1 just because it's better for neural networks. So we're going to normalize the data by dividing by 255 here. And then what we're going to do, maybe let's use a float here. Then what we're going to do is we're going to define our simple model. The model is going to be a sequential model, and it's going to have the following layers. We're going to start with a flatten layer, which is going to have the input shape 28, 28, because that is the dimension, or these are the dimensions of the images of the handwritten digits. Then we're going to have, actually I didn't want to run this yet. Then after this flatten layer, we want to have a dense layer with 128 neurons with an activation function ReLU, so rectified linear unit. Then we'll want to have a dropout layer for normalization, for regularization, not for normalization. And then in the end, we want to have a dense layer with 10 neurons representing the 10 digits with the activation softmax, so that all the results add up to 100%. But the model is not really that important. The data set is also not that important. We want to just see what happens when we train the model with callbacks. So we're going to say here, the normal process, model, compile. We're going to use an atom optimizer with a learning rate of 0.01 in the beginning. The loss function is going to be a sparse categorical cross entropy. And the metrics that we want to keep track of are just the accuracy. There you go. All right, so this creates the model, compiles the model. In my case, I also get a bunch of warning messages here, and actually I also get a problem. What's the problem? This should, where's the line that produces the problem? Keras datasets import mnist. This should actually not be a problem, so let me just restart the kernel. There you go, I get a bunch of warning messages and the model is compiled, okay. So this worked, and now what we do, of course, is we just do a model fit. So this is the usual process. You just fit the model onto the data. We provide the X train data and the Y train data to train the model. Let me just remove this message here. So we fit the model. We define, for example, we want to have 5 epochs or something. We want to use validation data, even though this should not be used for validation, but let's use the test data here. So the validation underscore data is going to be equal to the test data. And that's basically it. So this is how you fit the model. And that's the default behavior. You just run through the epochs and you get a trained model. Then you can save it. You can evaluate it. You can make predictions with it. But that's the basic process. Now, you can see nothing was created here. This is just our notebook. We now have the model. We can save it and so on. But that's it. What we can do now is we can customize this behavior by adding callbacks. So one very simple callback is the model checkpoint callback. Now the model checkpoint callback, as the name already says, saves the model in checkpoints. So we have certain checkpoints where we say, now at this point I want to save a version of the model, and we do that according to certain criteria. So what I'm going to do here first is I'm going to say from tensorflow.keras.callbacks import model checkpoint. And now before I call the fit function, but after I compile the model, so I'm going to run this again, I'm going to say here model checkpoint callback is equal to model checkpoint, and here now I have to pass a bunch of parameters. Now what you can always do is you can go to the API and look at the default parameters. So if you want to have something that's already set here to the according value, you don't need to specify it manually. So in this case now what I want to do is I want to monitor the validation loss. Since this is already being done here by default, I don't need to specify that. What I do need to specify is the file path. So the file path is basically a directory where I want to store the model, or actually this is the final file where I want to store the model. But the good thing here is I can also specify or I can also include parameters here. So for example, I can say saved models/model.keras. This would be one way to do that. Then I would just have one file where the model is being saved all the time. Or I can add parameters to the model. So I can say, for example, model and then epoch in curly brackets. And then, for example, colon 0 to D. And this will then save the model for the respective epoch. So this is a variable that is going to be replaced, and then we're going to get model, epoch, and then .keras. So this is a way in which you can save multiple models. So what else do we have? We have the verbose parameter. If you want to see more information, you can set this to 2, for example, which is what I'm going to do here. I want to have verbose equal to 2, just so I can see as much as possible. And then we have also save best only, save weights only. Now we're going to leave save weights only equal to false, but we're going to set save best only to true because we only want to save a model if it's better than before. So we're going to say save best model equals true. And what else do we have? We have the save frequency every epoch. We have the mode auto. We're going to leave that. So this is actually all we're going to set here. So we have defined a file path with a parameter in here for the epoch. We have verbose equal to 2. We have save best only equal to true. And now the only thing that we need to do to actually do this model checkpoint saving is we need to say callbacks in the fit function here. Callbacks is equal to a list, and this list includes the model checkpoint callback. When I run this now, you're going to see that it trains the model, and you can see here I get a message, epoch 1 validation loss improved from infinity to this, and then as you can see every time it improves, it saves a version of the model. So model 1 Keras, model 2 Keras, 3, 4, and here now it did not improve, so we don't save a model. And you can see that the models are now stored in this save models directory. So this is an example for a callback. This is a built-in callback, so I don't need to code in the logic. But what happens here is I have a model checkpoint callback. I define that I want to have it saved in this path. I want to only save the better model. So when things get better, I use the validation loss as a criteria. This is the default parameter, and then I just pass it as a callback and the new behavior is implemented. Now we can do that with all sorts of callbacks here. So for example, what I can do now is I can also import up here a different callback. Let's say, for example, the early stopping. The idea of early stopping is that when a certain metric is not improved for a certain number of epochs, we stop training. So even if I specify I want to train for 200 epochs, if after 10 epochs there's no improvement being made, then what I can do is I can early stop. I can basically interrupt the training process because there is no progress being made. So this is also something that we can define here. I'm going to say early stopping callback is equal to early stopping. And now what we're going to do, I think the default here is also the validation loss, so we don't need to specify this. But what you definitely want to specify is the patience. And the patience basically tells you how many epochs can you tolerate without an improvement before you stop training. So maybe you can have one epoch where the metric is not improved, but maybe you don't want to have 10 epochs where the metric is not improved. So what we can do here is we can say patience equals 10. And then all we have to do is we have to just pass it here, early stopping. Now in this case, this cannot trigger because the patience is 10 and our epochs are 5. So I'm going to set this to 50 and then I'm going to run this. And you're going to see that what we're keeping track of is the validation loss. So we can look at this number and the number has to be improved. So it has to get smaller. Now you can see here for the model checkpoint already that this is not improving. So after a certain number of epochs, here it stopped actually improving in epoch 2. And in epoch 11, we can see it terminates because there is no improvement. If I set this equal to 2, what's going to happen is that after 2 epochs without improvement, this is going to already terminate. So in this case, not improved, terminated, early stopping. All right, so that's that. Then we also have, I want to just show, I think, 2 more, and then I want to show you how you can define your own custom callback. I want to also show you now the learning rate scheduler. This is basically the idea that you don't want to have the same learning rate. You don't want to have 0.01 all the time, but you want to adjust the learning rate as you go on. So maybe in the beginning you want to take bigger steps, but then you want to decrease the learning rate to get to these smaller optimizations in the function, which is the neural network basically. So what we're going to do here is we're going to say LR scheduler callback is going to be equal to learning rate scheduler. Now this is going to take a function as a parameter, and this function will be a scheduler. So I'm going to say here import math. I'm going to define the scheduler function, and this takes as a parameter an epoch and a learning rate. So the current epoch and the current learning rate, and based on that we can return a new learning rate. So I can say, for example, in the first 5 epochs I want to have a certain learning rate. So if epoch is less than 5, what I want to do is I want to say just return the learning rate as it is. And otherwise, if we're after 5 epochs, what I want to do is I want to exponentially decrease the learning rate. So I want to say the learning rate should be, for example, math.exponential, so e to the power of negative 0.1. So learning rate times e to the power of negative 0.1. And this is going to decrease the learning rate exponentially. You can also do it differently if you want to. But that would be one example. So what I could do here is I can just pass scheduler, and I can also print here so we can monitor this. Learning rate, and then I can say it's the LR, and then I just have to add this here as an additional callback, learning rate scheduler. And when I run this, you're going to see we get a learning rate here in the beginning, which due to floating point imprecision, actually I think we have a problem because of the early stopping. So let me just set this to 20 epochs, otherwise we can never get to the 5th epoch. So we can see learning rate here, and what happens then is after a certain point, this learning rate decreases exponentially. As you can see, it goes down. So we're getting to smaller and smaller improvements here. But actually the validation loss is not improving in this case, so it's not really effective. But the idea that you can schedule the learning rate, that it can adjust or it can be adjusted based on the epoch that it's currently in, this is a very powerful idea, because sometimes you want to take very large steps to find a good spot in the graph or in your function. And then you want to take smaller optimizations as you go on, because you want to find like, you don't want to lose what you already have, but you want to optimize where you are at right now. That's the basic idea. Finally, what I want to show you is the Tensorboard. So we can also say Tensorboard here, and this basically logs the training progress and allows us to then look at it in the Tensorboard dashboard. So we're going to say Tensorboard callback is going to be equal to Tensorboard, and this Tensorboard takes the direction, or actually the parameter of the logging directory. So I'm going to say logs here, and update frequency is going to be equal to 1. So then we're going to just pass the Tensorboard. I'm going to run this, and this should then I think after, maybe let me do the early stopping here after 10 epochs. So let's do this again. Because in the Tensorboard we can see a bunch of things. Maybe I'm going to make a more comprehensive tutorial on Tensorboard itself, because it's quite comprehensive. But the basic thing is you can look at the loss, you can look at the accuracy, you can look at the learning rate over time, and you can see everything graphically easily. I think if you want to look at it, you actually have to install Tensorboard as well. So pip install Tensorboard, and then you have to go to the directory. So in this case, I'm going to go to logs, and I'm going to say Tensorboard, and then I think it was logdir equals logs. And then I should be able to see, I think I can actually open it already when I'm training. Oh, now it's improving, so it's not gonna terminate that quickly. But maybe I can already do that. Let's see. And what I see here now is, hopefully, if I go to scalars, epoch accuracy, there you go. So while it's still training, I can see that, how the accuracy of the training and validation data goes up. I can also see what happens with the learning rate. Here you can see the exponential decrease. We should also be able to see the loss. So you can see this is actually not a very good sign. We can see that the training loss is going down radically, and the validation loss not so much. This seems to indicate overfitting of the training data. But basically whatever is happening here, you can see in the Tensorboard. I don't want to make a tutorial here now on the Tensorboard, but that's another callback. So the last thing I want to show you is how you can also customize or create your own customized callback. For this, all you have to do is you have to import the base class here, so callback. And then you want to create a class, let's say, for example, custom logger, and you want to inherit from callback. And here now I'm going to define an init method. I'm going to call, actually I didn't want to run this. I want to call here the super constructor. So the parent class basically. And then I want to define, for example, a log file. So I want to, when I define this logger, I want to specify a log file. So I'm going to set self.logfile equal to log file. And then we have a bunch of methods that we can use here. You can look them up in the documentation. I think there should be somewhere here. Is it the base callback class? Yeah, you will find it in documentation, or maybe I will put a link in the description down below. You'll find the instructions and all the different methods that you can use. But one method that you can use, for example, is the onEpochEnd. OnEpochEnd means that this function is going to be called at the end of an epoch. So if I say def onEpochEnd, and I pass here as a parameter self epoch and logs, this is the function that is going to be called from this callback class at the end of an epoch. So at the end of an epoch, I want to log something to a file. So let's say I want to do here with open, and then of course self.logfile. I want to open this in appending mode plus so that I can also create a file as f, and then I want to do f write, and I want to write the following thing here, epoch, and then validation loss. And to get the validation loss, I need to go to logs, and then I think it was val loss. And then, you know, some custom stuff here, whatever you want to do. And it doesn't have to be writing to a file. You can also connect to a database and do whatever you want to. You can, for example, write all of this information into a database. Whatever you put here will be executed at the end of a training epoch. So I can do that. I can then also go ahead and say custom logger cb equals custom logger. And I can say my file is mylog.txt. And then I can just add this here, custom logger cb. I can run this, and this will hopefully not crash at the end of an epoch here, but create a file, which is mylog.txt. And there you go. You can see that at the end of each epoch in here, you will see, okay, actually I should probably add a line break there. So I should probably say \n, but besides that, it works. So yeah, I'm not going to run this again now, but this is how you can also create your custom behavior. So callbacks are very useful to customize the training process. A lot of them are useful, or a lot of useful callbacks are already part of Keras. So you can just use model checkpoint, early stopping, learning rate scheduler is very, very useful. And if you don't find what you're looking for, you can also define your own custom logger or custom callback. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.